Awesome. Hey everybody, I'm Ty. I work at Uber on the platform team. I spend a lot of my time thinking about how to make our apps not explode and be able to scale and keep reliable for our customers. So today we're going to be talking about a lot of how I think about third-party libraries and how that relates to making folks more productive as well as keeping your apps reliable. So I don't know if you guys remember where you were back in April 2020. This is right after COVID had just kicked off. Most of us were working from home, trying to figure out what even was going to happen in the world. But I remember this especially well because my remote is jumping through a ton of things without me. Okay, interesting. I remember it because of technical difficulties in a Google slide. Let me pop this back up real quick. Presenter view, and let's see if this works a little bit better the second time around. Full screen. Okay, I'll just use my keyboard. I'm afraid of this remote now. So I got a page on PagerDuty, and it was for all of our apps. We figured out that around this time, all of our apps had started crashing. We started seeing a spike in this, and it wasn't just our app. If you remember this time, pretty much every app that was using Google Maps on Android and iOS in the ecosystem started crashing around the same time. Now, for a large business who relies on navigation and the map like Uber, this was just a showstopper for us. Like our apps were dead in the water. And Google, public threads very quickly started. People were reporting this. Hundreds of comments were going on. There were, our BD folks were reaching out to Google and talking to them. There were private channels going on with, Google developers and our company, and all the other companies were kind of doing the same thing. And so let's walk through maybe a quick timeline of what that outage looked like. So around 11:30, that incident was detected by both us and Google. They started a rollback of a server-side change that they had rolled out. And they started this a couple hours later and told us, hey, we've rolled this back, everything's going to be fine. And so we were monitoring it, but we realized the crashes weren't stopping. And so by Friday at 4 a.m., Google updated us and said, actually, while new users aren't going to keep crashing, every user who had experienced a crash is going to be stuck until you roll out a programmatic fix to delete a cached file, or we get around to doing a play services update several days from now. And so we started a hotfix process, but if you have ever tried to roll out an app update on Android or iOS, you know that can take a while. So we kicked off the hotfix, and in parallel, we do have an alternate mapping system that we use in some markets called Uber Maps. We had acquired them from Microsoft back in the day, but we use Google Maps in most markets. There's both technical reasons for that and contractual reasons, but we started an emergency process of rolling out Uber Maps as an alternative in several markets. Around 2, we released the first Android hotfix, and it started rolling out. And later that evening, Google gave us the code that we should release on iOS as well for a similar programmatic hotfix. And we began the process of rolling out that for iOS. We were still seeing crashes, and Google tells us the next day, hey, actually, we told you needed to do one thing, but there's a second file that you need to delete as well. And so we began a second hotfix. And that was also taking time to roll out. We were still having millions of users blocked. Finally, we were able to get legal sign-off working with Google, who was a partner in this, on rolling out Uber Maps in the remaining area. So Google released a public postmortem of this outage. It's a really interesting read. I have it linked down at the bottom. You can find that later when I post the slides. But here you'll see there's a massive spike in crashes in the entire ecosystem when they roll out the bad update. They roll that back, it starts dropping, but you have this long tail of crashes. And this looks small, but this is like hundreds of millions of users in this long tail. And this is many days later when they finally push a GMS core update that resolves it permanently. So there's this 4-day-ish time frame where there's still users that are affecting. So let's talk about the impact of this. This was probably the largest mobile specific outage that we've ever had at Uber. There were millions of users blocked. There were millions and millions of dollars lost, tens of millions. And then thousands of hours of developer productivity. People from all over the company, hundreds of engineers and product managers and BD people were involved in a 4-day around-the-clock incident trying to mitigate this and get our users operating. So some of the aftermath of this, of course, we did a company-wide executive postmortem, and the execs were very concerned. We established new intercompany legal agreements with Google on when we could use our own mapping product versus their mapping product in different markets, and what are the conditions for that. We really hardened and formalized our library governance policy. We'll be talking about that a lot here in a little bit. And we really invested in programmatic crash protection and recovery. So we'll be covering those two as well in this talk. So let's take a minute and kind of talk about third-party code in your apps as a concept. So third-party code's great, right? We use it all the time in Android. All the Square libraries, the Google libraries, the Uber open source libraries, right? These are all, the entire app platform is built on this giant stack of open source code. It's awesome. We can have a modern platform without, even with old manufactured devices. We have new features, even on older API versions. We get free maintenance from open source developers. If you look at the modern developer stack, it may look something like this. You have your app code, and it's built on an entire stack of open source libraries. And I love this XKCD comic where they're referencing the infrastructure we have today. It's this giant tower of open source, and then there's this one random maintainer that's doing some very critical library that everybody's infrastructure depends on. And so if we start to think about the cons of third-party code, I think there's a lot as well. A crash in third-party code is a crash in your app. Security vulnerability there is also in yours. There's compliance issues or legal problems, or their permissions are out of control, or they degrade your app's performance. All of this also affects your application. Your users don't care if it's your code or a library that you're using. So if you go back to this visual, I start to wonder if it looks a little bit more like this. So this is what happened with Google Maps, right? So let's talk about three kind of categories in this talk. We'll talk about the policy to think about how you evaluate and decide when to use third-party code or not. Talk about some techniques you can use programmatically to help make your app more reliable and protect against that. And then in the event of an outage, what you can do to try to make that a little faster to recover. So what is library governance? I asked Bard, because I was looking for a great definition, and it probably hallucinated this. But this is a company process to try to make you choose the best code, right? It has to be reliable. It has to help your teams be more efficient. It has to be forward-facing. It has to align to all of your, the traits and how you decide on code internally. And I think it's worth thinking about, this usually matures as a company gets bigger. If you start with a seed startup, there's probably no policy at all. It's just use whatever is fastest to hit the market. And you start to scale that company up, and maybe there's some tech leads or some senior engineers who start to have opinions and start to decide which should and shouldn't be used, and it's very subjective. You get to medium-sized companies, and maybe there's a team who starts to own it or be the main consultant on it. And then finally, in larger companies like a Google or an Uber or a Meta, you might have a very well-defined objective set of library governance and the people responsible and what exceptions look like and all of that. And so this, was our journey in going from medium-sized to large enterprise, going from following the Google Maps outage. So let's talk about setting this up. First, it's important to align this to your own business priorities. For Uber, we're an app that focuses heavily on reliability because people use the app to put food on their table if they're a driver, or go to the hospital, or go to their job. And we can take some other trade-offs potentially, but reliability is number one for us. You want to define the specific requirements in the libraries and how you're being objective with evaluating these. You want to define who's responsible internally for making these decisions and handling that and having the authority and what empowerment they have. And you want to define what that review process looks like so that when people are going through that, they understand it. It doesn't feel thrashy. It doesn't feel ambiguous. And then obviously, you won't always have something that fits in the standard definition. So what do exceptions look like? How does that work? And lastly, very related to new code, upgrades are pretty similar. They carry a lot of similar risk. And so that's important to kind of think about in this process as well. So we talked about the business priorities and establishing those. So I think there's a few common ones that companies think about. Speed to market. They don't want to write all this stuff themselves. They just take an off-the-shelf solution. Making their developers faster. They're not having to spend their time working on that or have headcount on that project so they can focus on other things. The app quality. They want to use things that make their app better for their users. And then finally, they want to choose things that they can build on for the future. They don't want to necessarily have picked something that introduces tech debt. And so, if we go back to Uber's example, I mentioned that reliability is kind of our #1 priority. And, sometimes we've made other trade-offs in that list for reliability. We've said, okay, we can take a slight performance degradation as long as it's more stable, or we can have teams spend a little more time internally working on this as long as it's more stable. And so if you go back to this list, I stack ranked this the way we think about this, where app quality and reliability is #1 for us, the long-term foundation and scale of the business is #2, then speed to market, and then developer velocity and staffing. Obviously, all of these are important. I'm not saying this is like important and not important, but if you were to stack rank these and we did have to make trade-offs, this is how we think about it. So in moving on to defining how you evaluate them all together, this comes back to evaluating on what makes sense for your company. Here's several high-level concepts that we think about. Is the license correct? Is it secure? Are they handling permissions correctly? Is it stable, both from an API perspective and a crash perspective, as well as it's not doing crazy stuff like dynamic updates from a server? Is it mature? Is it kind of the industry best solution? If there's 10 of these in the wild that are being used in the community, is this the de facto one that the industry is moving towards? And then a bunch of these others that seem to make sense. Moving on a little bit, I mentioned that you need to have an empowered body internally, a governance body. So this can be, maybe it's a platform team, maybe it's a very senior engineer who runs this, maybe it's a guild, but this group should be both responsible for this, for defining it, and empowered by leadership, right? Sometimes they'll have to make hard decisions that other folks aren't happy with. They'll have to say, no, this doesn't meet the requirements, and you'll have people that say, but we really want it, and they'll have to fight that and have those battles internally. And so, it's important that they have that empowerment, that they have the executive buy-in, that these are the people in positions of authority that can drive this successfully in your organization. Then, I just kind of threw this word cloud together, thinking about what are some of the traits that you want to think about in the review process. If you're just an engineer on a team who wants to use this library, and you're throwing it up against this black box of a system, of a process, and you're I don't even know how these folks evaluate this, or it feels very subjective, it feels unfair. And so we try to think about making this as transparent to our developers as possible, make it very consistent. So if you took 2 types of libraries, that it would be a similar result coming out of it, that we automate as much of it as possible, that it's not subjective, and that when the developers go through this process, that they're educated on the needs of the company, and that they could run this themselves, and that they can turn around and advocate with their peers, hey, we shouldn't use this library because this is what we care about at Uber, and we should use this, and they can turn around and become an ambassador for that internally. But of course, there's going to be exceptions, and these should be extremely rare, right? When those happen, it's because your process didn't otherwise account for that. And so, what we typically do is when that happens, we make sure that's a very rare, that there's a large amount of overhead to making that happen, that there's a large amount of business needs for that exception to even be considered. And then that when that happens, we do a retro on the process and say, do we need to change the process with the learnings from this exception? Let's talk about upgrades a little bit as the last part of governance, or one of the last parts. There's this concept of green keeping that you probably have seen, right? If you look at Dependabot on GitHub, it's automatically updating libraries. This is pretty popular both internally and externally. But in mobile, it has potentially a lot of risk, right? Because if you roll out an update, it could have some of these reliability concerns because it was new code that was introduced. So there's a lot of shared risks that come with just adding new code. And so we tend to do intentional updates in mobile, where in the backend we're a little more aggressive in trying to be as modern as possible. But we do think about this from the perspective of there's like platform type of libraries that we want to always be modern and developers to have the latest features, like the latest versions of Kotlin or RxJava or different things like that. But then there's feature-oriented third-party code that we only want to update when there's an actual business need for it. Like there's a new feature in that QR code scanning library that they need, or there's a bug fix in it that team needs. Otherwise, we let those typically go stale or be stable because the risk of updating those and rolling those out can be higher. And then noting that there's a large organizational cost to updates, right? If you have the larger amount of code you have, the more expensive that can be. Maybe migrations are required, maybe additional verification is required. So noting that there is this cost associated with keeping upgrades going. So let's walk through a couple examples of some of the libraries that we've evaluated internally and what the results of this process kind of decided. First, we use Coil for image loading with Compose. This was proposed last year, and this was a pretty straightforward library to evaluate. It had a bunch of good traits. It was good licensing, it was small, it had a good use case, it was very testable, it was pretty well used in the industry, pretty standard in that direction, not doing anything crazy with like outside servers or any dynamic code. It was maintained well, overall good quality. So this was a pretty easy decision. And so we decided, yes, let's take this into our monorepo. Then a team came and they proposed, hey, we're the identity team and we want to be able to log in with Facebook, and they have an SDK and we want to use that. And it had a pretty good business use case, and it was open sourced, and security scans passed, and it was well tested. But it had a weird proprietary license, and it was using outside Facebook infrastructure, and it was pretty complex overall for what it was doing. And there's a pretty feasible web solution, right? You can just use Chrome custom tabs and log in there, and it's only a somewhat degraded user experience. And so we decided, no, we're gonna pass on this, and we're gonna recommend the team go with the web solution instead. And what was funny is a couple months after that, there was a similar ecosystem outage caused by the Facebook Auth SDK that we entirely avoided, but a lot of apps did not. So we can specifically point out the impact that this process has had by avoiding an outage and put some dollar amounts to that. We'll walk through one more. We had a team in our driver app, and they provide a lot of support for our driver partners. And a lot of those folks, they come into like support centers in different cities to get help with the app or with different things. And during COVID, that was hard potentially for them to come on site and get assistance. And so they wanted to use this, video SDK from Twilio that was, built on WebRTC, and do like screen sharing and be able to do support in the app and share it. So there's a pretty compelling business use case for this. But there was a lot of downsides to this one as well. It was proprietary, it was this closed source, large binary. And if we were to build this ourselves, we'd have to have like a full WebRTC team and set up all this, and it'd be, we'd have to fund a long-term team to have this, so that would be kind of expensive. And so, this doesn't necessarily make sense from our governance perspective, but the use case was really strong. And they were able to put a lot of dollar amounts to what that would save and how that would help drivers. And so we started working through what an exception might look like for that. And so for the closed source, we met with the Twilio SDK team. We did a full architecture review of it, and then we worked with them to sign a contract and hand the source code over to a third party for a clean room review. And we educated that third-party company on what is a platform review, what are the things we're looking at. They did security and the platform side and gave us a full analysis. And then for the binary size, we were able to package that in a dynamic feature module and roll that only out to the users that needed it, and it wasn't accounted for in the main install. And so we were able to roll this out and see the wins for this. So let's move on from the policy side into some of the technical defense that we can think about. So it's important to have a little bit of context in mobile development when we think about the life of a commit, when it goes from you working on it to when it's in the hand of a customer. For us at Uber, we have a build train that runs weekly, and so there's 1 week of active development. On Mondays, the build train cuts. It then begins release testing and an employee rollout and a public beta rollout. The next week, it begins rolling out to the customer from 0 to 100 over that week. And even when that's at 100, users haven't always updated to this. If you look at Google Play, we only see about 40% of our users have updated within the first week. And that slowly creeps up over the next 4 weeks before we even get to 90%. And it takes 6 months to a year before the long tail of users have necessarily updated to a version. So if there was a bug that was introduced, you might have users that are experiencing that bug for a year, right? So we like to think about preventing bugs in general, kind of the Swiss cheese model that security references, where you need a ton of different filters that are targeting different traits, and you want to be able to catch those in these different filtering mechanisms. And so, we start to think about some defense gates. And this isn't an exhaustive list. This is just a set that, I thought would be useful for discussion here, and some that are especially helpful with third-party code. We have the library governance process itself, and then we have, a few of these that we're going to talk about, like, linters or scanning the dependencies or testing. And then, in production, we have some things like the dynamic features that I mentioned or monitoring. So let's dive in to a handful of these tactically. First, one thing we make heavy use of is feature flags. If you're not familiar with a feature flag, this is essentially you have a server that tells the app if a user can run code or not. It's like an if condition with a server backend. There's plenty of public companies like Optimizely or other ones that offer this as a service. Most of the big companies kind of have an internal service that powers this as well. And so, if you're using third-party code, you may have something like this, an activity, it has a function that uses the SDK. And if you were to wrap that in a feature flag, it's going to look, something more like this, where you get it from the server, and then you say, if the user is enabled for this, we do it. Otherwise, we have some fallback experience, or we don't show it at all. And so to kind of continue in thinking about this sets of defense, the next one that we make heavy use of is delayed initialization of third-party code. So a lot of third-party libraries, they aggressively ask to be initialized early. They're like, hey, put us in your application on create, call initialize or different things like that. And we found that that's very rarely needed. And if a crash happened here in your application on create, like that's going to be detrimental to your app startup, right? And so why not just put your feature flag here and say, well, we'll see if the user's applicable, and if there's a crash, we can just disable that, and this would work, right? Well, then as soon as you put that in place, you might see this strict mode violation because you were just trying to check something blocking on the main thread, and you were blocking startup to try to get the feature flag information and make this decision, and you start to degrade the user experience for this trade-off. And so then you might say, well, why don't I just make this async? I can, maybe my feature flag API can take a dispatcher or a scheduler or run this in a Lambda or something. So here we pass the IO dispatcher, and we say, cool, we'll kick off this thread, and it's going to start the SDK once the feature flag comes back and says this thing is applicable. That might work. But what we typically do is we recommend that folks move the third-party code usage to as close to the site where the user is going to be needing it as possible. So in this case, we moved it from the application to maybe the specific activity that is being used for the user to use this specific feature. But then you get into some scary ones that you might not account for. Like Google Play Ads was another example that we had to run through our exception process. And one thing it does is it has startup code that you don't ever actually call or you don't start. And how does it do that? Well, you just set a dependency, and all of a sudden you have code running in your application that can crash. Well, what they do internally is they have a content provider, and that content provider sets, has their startup code. They want to do some verification to make sure you set up an API key successfully, yada, yada, yada. And you're like, okay, still, maybe that runs later in the app. We could probably do our app startup, and we could feature flag that. But if you go look at the documentation for the Android lifecycles, you'll see this really interesting note here that application on create is called before everything except content providers. So then that gets really scary because you have something like this where your application starts and the third-party code that you have no control over runs before any of your own code to even set up your Crashlytics handler to even catch this. And in this case, this could crash and you might never even know. And so what we did for this one is we used an APT flag to prevent manifest merging of this content provider, because this wasn't actually functionally needed for the usage of this. This was just checking like your API key was set up successfully for the developer, and we didn't want to risk that because Google Play Services is doing other scary things like dynamically updating outside the control of your application, and we didn't want potential surface area for them to update startup code that we had no flags on. There's other types of bundled code that can run outside of your context. You could have broadcast receivers, intent filters. Content providers, like I mentioned, like JNI native callbacks, potentially AIDLs. A lot of these can unintentionally run code that you're not expecting. And if those cause crashes, those are your crashes to handle. I mentioned Play Services. This is especially a pain point of me, and so I want to have this dedicated section to this. Why am I talking about Play Services? Well, one, it's opaque. Pretty much all of it's closed source. So if there are issues, they're very hard to debug or fix. Two, this runs with system level permissions. So your app is running in user level. This thing has escalated permissions for Android, and it's doing a lot of crazy stuff that your app could never do. It's running dynamic behavior outside of your app's release cadence. So they even do updates, dynamic updates of Play Services, and your app is binding to that through Play Services ads or Google Pay or MLKit or all of the other ones that Google Maps. And those are updating inside your application through an AIDL outside of your app's control. And they run XP and feature flags inside your app as well with outside servers. All that sounds scary from the example I gave with Google Maps, where their specific behavior caused a major outage. So how do we handle this, right? Google provides the platform, they're in control, right? Well, if you think about how your app is typically constructed, something like this might happen. You have these Play Services libraries, they're talking to Play Services, which is handling most of the business logic in a separate process. It's over an IPC, it's doing some of that stuff I talked about, updates and feature flags and dynamic loading, and maybe has the potential to bring down your app without you even rolling out an update. And so what we've started to do is we've started to sandbox every single Play Services library inside of a dynamic feature module that we have granular control in our feature flagging library of installing or uninstalling. So that in the event of we start to detect outages, we can roll out feature flags through our crash recovery system I'll talk about in a little bit that will uninstall specific Play Services libraries. And then all the teams that are using these have to handle the fallback cases. So here's a little bit at a pseudocode level of how that might look. You might have a couple feature flags. One is to install the SDK, and one is to initialize the SDK. We can check the install SDK flag. If it's enabled for the user, we run the Google Play APIs to install the feature split. And once that's done, then we can check the second feature flag, and we can initialize the SDK once that's in place. And this gives us very granular control, especially in thinking about detecting crashes or investigating stuff. We can enable one and not the other, and we can see what the behavior is. We can disable it altogether. So this has been super useful for us. Moving on a little bit, another potential issue in defense is transitive dependency conflicts. So here's a fake example where we have our app and it has two foo and bar libraries, and both of those have dependencies on RxJava, but different versions of RxJava. Now, what happens when this is declared, right? When you have this conflict between two versions? Well, Gradle's default behavior is to pick the greatest. You can set conflict resolution strategies, but that's the default. And that might work fine for your build system, because that was 2.1 to 2.2. They followed proper semantic versioning. They didn't break an API. Your build system's like, great, okay, this handles properly. But we all know that new bugs are introduced, or you might have had code that relied on buggy behavior before, and so this can cause runtime issues, right? You could have this old library that was foo that's now using RxJava 2, and it's causing a crash in your application. So wouldn't it be better in this case, if we could have some kind of concept like this, where foo is still using the proper version to RxJava and bar is using the new one, and then that gives us some guarantees of runtime stability. And so that is where we get to jar shading, which is another concept in the JVM world. There's a popular plugin called jar. There's some others as well. This allows you to take a group of dependencies and repackage a specific thing into a new package space, so that you can, in your app, then have essentially two bundled versions of an application. Now, this sounds great, right? You get dependency stability. You can support multiple versions. But there's a lot of downsides to this. Now you're bundling multiple transitive graphs of dependencies, and that might not just be one or two. That might be all of the transitive underneath that. So your app binary size can start to increase a lot. Your nested dependency, that I mentioned the complexity, and then the maintenance of this can be really painful. And so I would recommend only using this as a last resort, for really specific examples when you can't update the other things that are using this to the newer version to keep it consistent. Another concept we'll talk about is abstraction of libraries. And so I kind of break this down into two. One is the local abstractions. Like in your code, you have a library you want to use. You write a wrapper on top of that. That can be useful when dealing with like utilities that have unstable APIs. Like maybe it's not productionized yet, and they're going to be changing that frequently, and you want to give it a stable API so that your consumers don't have to migrate consistently. Maybe you need to add better testability or feature flagging to this, and you want to do that in a consistent way. Or potentially you want to replace a heavy SDK with maybe all it was doing was hitting some REST APIs, and you want to rewrite that with retrofit. We actually have done this with several third-party SDKs, where instead of pulling in the full thing, we just wrote a very light REST wrapper and hit their services. And then there's server abstractions, right? Instead of putting that code in your app altogether, if you have infrastructure at your company, why not put this logic on your server side and have them handle that, and then your client should be agnostic of this, which is typically one of the more preferred recommendations. The last one I'll talk about in the defense techniques is linters. This can be really useful for banning known dangerous APIs. Maybe you've used a library, it had an API that was causing some crashes. You said, well, they shouldn't use that one, they should use this other. So you can ban that. Or for shifting runtime exceptions into build time exceptions, shifting that left so that your developers run into it during the dev cycle and can fix that before it rolls out and affects your customers. So I'll give a concrete example that we ran into. Here's a dummy usage of Picasso. You get an image from a server. So our server returns back a URL that should show an image. And we call picasso.load and throw that into a view. And it causes a runtime crash for all of our users. Because if you go look at Picasso's code, they have this verification right in there that says the string can't be empty. And if the server happened to return an empty string because that was a bug on their side or whatever, like those sorts of things happen, that's not causing a crash for your users. And you might argue, like we did, that that's not probably the right behavior, that if there's just a missing image, that maybe we just don't want to show that image and the users can continue. Maybe that doesn't need to be like a hard piece of failure there. And so we wrote a function extension, and we called load safely, and it checks if it's empty, and it throws Lumber is our internal wrapper that sends up analytics and exceptions. And so in this case, we send up the exception to our analytics reporting system. In development, this will crash and give developer the same fast feedback, but in production, this is going to return gracefully and not crash the user. And then we have a big shared banner map that has an error-prone and a detect integration that we can add a bunch of banned things to. And we added this entry where we say, no user should be using .load. This is dangerous. There is a load safely extension. You should be using this instead. So let's move on to the last section of my talk. We talked about crash defense. Now let's talk about once the crash is actually happening, recovering from the crash. So let's assume that the crash has started, right? There's a golden path for handling an incident. Non-call alert is probably triggered because you had good observability, right? There's a team responsible for handling that. They saw the bug. They start to triage that. They say, great, well, this was behind a feature flag. We can just roll back this feature flag and we can save our users. So they roll that back and they monitor and they see the crashes starting to drop. And then they're like, cool, it's all fixed. And they go write a postmortem and then they fix the bug for the future version of the application rollout. This is great if you don't have this at your company, if you don't have the operational maturity to have like a good incident observability. Number one, I would recommend getting there. But if you have that, then we'll get into some other interesting cases. When that doesn't work, what happens if you can't feature flag this? What happens if it's crashing anyway? So we have some interesting automated crash recovery systems that are built into our applications. And we also allow for push-based recovery, so we can send specific signal over Google Play pushes that the app will receive and either update feature flags or handle specific recovery actions, and we can do that for targeted groups of users. And then one of the ideas we're thinking about building, but haven't yet, but I'll go over it anyway, is a multi-process recovery agent, or like a Sentinel sort of agent. And then we can talk about hot fixes and force upgrades as kind of a last resort. So first, let's go over the automated crash recovery. This is a system we have called Black Swan that we built internally. What this does is when the application boots, it writes a file that signals that the boot has started. It then starts to do the normal application startup. It runs through a set of startup steps. When those are done, it removes the file to indicate, hey, this completed successfully. It's the lightest synchronous operation that we can do on the main thread. It's a touch and a remove on the file. It is main thread blocking, but it is important for the recovery, and it's as light as possible that we can do. And in the event of a crash where this didn't complete, on the next start, it says, hey, this file still exists. We had a startup crash last time. We should probably try to handle this in our recovery engine. And this is a rule engine that starts to then run a series of recovery steps based on the number of startup crashes that it's received. And so this is configurable per app, and our apps do configure this in slightly different ways with different thresholds. But what a typical example looks like is on the first crash, it retries. Maybe it was just a fluke. On the next one, it can clear cache. Then it can clear all the XPs and go back to a default state. Then it can clear app data altogether, including auth tokens. And if we continue to have crashes, then it'll end up falling back to a web view experience and try to remove as much native functionality as possible. And then I mentioned we have server-based rules. And so this is built into our XP system. And so we can send out push notifications that tell feature flags to update. So if we have seen a crash already happening, but users haven't necessarily opened the app and experienced the crash, but we know they're going to, we can go ahead and push the feature flag to them in advance so they'll never experience the crash. We can also push custom recovery actions. We built this after the Google Maps crash when they told us you need to delete a custom file. We thought, well, wouldn't it have been great if we could have just pushed to our recovery engine, delete this specific file, instead of having to roll out a programmatic update? And so we built some custom business logic that we can do push-based mechanisms with. And then we have another last resort where we have a custom engine built into our networking library that checks a custom DNS record with a 0 TTL. That's the fastest possible network transmission. We found that faster even than like a quick-based API call to like AWS. And with that, we can flag all of our apps to head over to a backup infrastructure. And that way we can use that for remote config and doing some custom recovery. Now, it's kind of an all or nothing. Like there's no granularity in that for the app version or feature flags or anything like that. So that's kind of like a final resort that we could potentially use. And then, I mentioned this multi-process agent, this idea we're thinking about. I've heard some other companies kind of pursue something similar, but like I said, this is entirely theoretical right now. My idea here is that we can move all the recovery actions and things like XP and the remote config stuff into a separate process that's much more stabilized, and then have the business logic live in a normal app process like normal. And if that crashes, if that goes down, your main your recovery process is going to stay alive, and it can do more advanced things like report on that in real time, try to manipulate things, try to recover from specific crashes. And right now we're working on a specific migration where we expect there's this very specific type of crash that might happen if we do this wrong, and we can actually check that in the recovery action and only reset a specific XP for that one specific call site, and the user can recover on their own on the very next start. And so like this sort of thing gives us very granular control in that type of direction. Lastly, if none of that works, you're left with, well, we have to roll out a new update. Like we had to fix a bug, we had to fix a crash, we have to get this in our users' hands. Real-time migrations or mitigations are so much faster. We talked about how this can take forever. Even if you push this through and you escalate and you do force upgrades, like your users are going to be in a bad spot for a while. They also introduce additional risk, right? If people are under a sense of urgency to resolve an outage, they might be skipping other verification or testing that they normally do. I've seen one outage introduce a second outage because they rushed through a review of the hotfix. Lastly, force upgrades cause user attrition. The larger your app gets, the user might be using it for a specific behavior. They're like, for us, it's like, I want to get a ride. I'm done at the bar. My battery's low. They open the app and it says, sorry, you can't use this. You have to upgrade to a new version of Uber. They're just going to say, nah, I'll just call a taxi, right? Or I'll just take the subway, or I'll take a Lyft, or whatever, right? And so we see major attrition if we force upgrades, right? We have to be a lot more cautious with those. And so this is an expensive operation if we need to do this. Google Play does offer some nice APIs for this. You can prompt it passively or actively in the application, but this still has cost. So with that, those are kind of the 3 topics that we wanted to cover today. Policy on library governance and how to think about this in your organization, some techniques to kind of defend and harden your stack against code when it goes bad, and then finally, when things do go bad, how you can try to mitigate that and minimize some of the damage. With that, I'm done, and I think I'm perfect on time. That was 39 minutes, a little faster than my run-through. I can answer questions.